أعوذ بالشيطان الرجيم. بسم الله الرحمن الرحيم. In this unit, we will discuss about wireless propagation models which are used in wireless channel. We will address fundamental questions such as how electromagnetic signal propagate in the air, what is the wireless propagation model itself, and what are the different types of wireless propagation model? How can we differentiate large-scale propagation model and small-scale propagation model? And what are the different types of large-scale propagation model and similarly small-scale propagation model? All these fundamental questions will be discussed in today's unit. Understanding of electromagnetic signal propagation in space is very important for the design, analysis, and optimization of efficient wireless communication system. Electromagnetic signal, as you know, that travel at the speed of light in vacuum. It is approximately 3 to 10 power 8 meters per second. This speed is the fundamental constant of nature, and wireless signal, which is directly electromagnetic signal, is also move with the same speed. And wireless signal span a wide range of frequencies and wavelength forming the electromagnetic spectrum. Such spectrum includes various types of waves such as radio wave, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays. Each type of these waves has a unique frequency and wavelength. Intensity of wireless signal decrease with the square of the distance from the source and resulting in the decrease in the signal strength when it propagates through the free space. Wireless signal can be absorbed, reflected, or scattered when they encounter objects like mountains and high-rise buildings in their path. These interactions can result in change in the direction, amplitude, and polarization of the wave. Propagation model, also known as radio propagation model or wireless propagation model, basically a mathematical or empirical representation of how electromagnetic waves interact with the environment or propagate through the wireless communication channel. It describes the behavior of the wireless signal as it travels through a free space from a transmitter to a receiver, taking into account various factors that affect signal propagation. These free space wave propagation models can be classified or the theoretical principle, empirical measurement, or combination of these two, mathematical or empirical measurement. Modeling of a wireless communication channel requires very complex mathematics and incorporation of very large number of interactive channel parameters. Generally, these three-phase propagation models provide approximation and simplification of the complex and dynamic nature of wireless propagation. The validation and calibration of propagation models using measurement and field data are often performed to enhance their accuracy, reliability, and efficiency. Propagation model can be classified into two broad categories based on the scale of the environment. They are designed for representation. They can be classified as large scale propagation model as well as small scale propagation model. Large scale propagation model focus on the overall behavior of electromagnetic waves over long distance. They are primarily designed with factors such as path loss, shadowing, and fading due to obstacles, mountain, high-rise building, and some planning features. Large-scale models are useful for estimating signal coverage areas and determining the feasibility of establishing communication links over relatively large geographical areas. These models are less detailed and highly suitable for macroscopic analysis of wireless communication systems. On large-scale propagation models, some common type of models names are three-stage path loss model. This model predicts the attenuation of electromagnetic waves as they propagate through free space without any obstacle. It is designed on the inverse square law and is used to estimate the loss of a signal strength with this law. Similarly, two-ray ground reflected model. In this model, the transmitted signal travels along two paths. One is direct path and another is ground reflected path. Consider the direct path and the ground reflected path to estimate the received signal power. And third one is Okumura-Hata model. Okumura-Hata model. Basically, this model developed for urban and city area, which includes some empirical model takes into account such as distance, frequency, and terrain type to estimate the path. It is widely used for macrocellular network planning and design. And then finally, COS 231 Heta model is extension of the Akumura Hata model. The COS 231 Heta model incorporates further additional parameters such as base station height and frequency to improve the overall quality, accuracy, and reliability of the model. Small scale propagation model focus on the rapid fluctuation and variation in the signal strength over short distance. These models account for the effect of multipath propagation, which results from reflection, diffraction, and scattering of the wireless signal. Small scale models typically consider distance on the order of few wavelengths or even less. They provide detailed insight into the variation in signal strength caused by constructive as well as destructive interferences of multipath components in a communication channel. Maybe Fading model, one of the most important small scale propagation models, is statistically model, assume that the received signal experiences some random amplitude variation due to large number of uncorrelated multipath components. It is often used to model wireless channel with a rich scattering environment. Right-hand static model. This model accounts for both line of sight and multi-path components. It assumes that the received signal consists of dominant line of sight component and a number of scattering multi-path components with random amplitude. Nakagami-m static model. This model generalized Rayleigh and Ricean padding models and introduced the Nakagami and parameters to control the severity of padding. It can represent a range of padding conditions from severe multipath padding, where M is should be less than 1, to nearly deterministic padding, where M should be greater than 1. Finally, we can conclude this unit is that the rapid variation in signal strength caused by multipath propagation over short distances are addressed by small-scale propagation models, whereas a large-scale propagation model concentrate on the overall signal strength and attenuation over larger distance. Although they serve distinct purpose, both kind of models are essential for fully understanding the behavior of wireless channel. Thank you.